this live on YouTube and then we can start. All right, perfect. So hello everyone, welcome to today's webinar session. Thank you again for joining us. We are now on week 6, I think, of webinars, and we are announcing more for next week. We're going to keep going as long as we can. And today I'm really excited to have Marianne Porter, who is an assistant professor at Florida Atlantic University. She studies biomechanics, so shark skeletons, swimming, how they swim, and she also studies other animals like dolphins and manatees on occasion. But I'm going to let her tell us all about it herself because she can probably explain it way better than I can. And I'm very excited. So enjoy the talk, Marianne. The floor is all yours.
All right, thank you very much. Well, welcome everyone. I hope you are all doing well and staying healthy. Today, I want to tell you a little bit about some of my research, and I'm going to need you guys to pay attention because I'm going to show you how to look at the data the way I look at it. So I'm going to turn you all into researchers for my lab because I can't be in my lab right now. So it's going to be really useful to have you all help me, okay? So, like just said, we in my lab study biomechanics. And so biomechanics is just understanding how animals move. And we do this even though we don't think about it. So with your a lot taller than you. If you hold them and try to keep up with them, you actually have to walk really fast. Like my dad is very tall, and when I was a little kid, I remember I had to almost run to keep up with him while he was walking. And that's because his legs are a lot longer than mine. And this is actually something that we can look at and study with sharks too. Obviously, they don't have legs, so we're going to talk about how sharks wiggle and bend their body to produce different amounts of speed in different ways that they swim. All right. So here's a picture showing some of the things I study in my lab. So here's a picture of a blacktip shark. One of the things we study is shark skin. So how does shark skin help these animals swim faster? Another thing we look at is their backbone, so the spine of the shark. You all probably know that shark skeletons are made of cartilage. And so that's really different from our skeletons that are made of bone. So sometimes in my lab, we study cartilage and we think about how the skin and the bones or the cartilage work together to produce swimming in these different species. So what does a shark look like? We talked about the cartilage. Here is a really nice x-ray. Whenever you go to the doctor, if you've ever had to get an x-ray, your bones show up on the x-ray because they have a lot of mineral in them. So the things that kind of make your bones really strong. And it turns out that sharks have this in their cartilage. So remember, they don't have bone, but they have a lot of mineral in their cartilage. And we can see that in some of these important bits. We can see a bunch of mineral right here in this white part of the here, this big clump of mineral right here, those are actually the jaws. So we have the upper and the lower ear. We also have the vertebrae. So the pieces that make up the spine of the shark are right here. And this is a horn shark from California. So we can see these really nice spines on the top of this, which is pretty cool. So I'm able to study cartilage in my lab. And I like to think about how this bit, the vertebral column, wiggles around and how it wiggles around in actual sharks to produce swimming. So here we have a close-up of this vertebral column. And if anyone has ever played with those candy necklaces, you know what I'm talking about? The ones that have all the little pieces of candy. You know that if you have a bunch of small pieces of candy, your necklace is going to wiggle a little bit differently than if you had very large. So we know that how this skeleton works and is put together is really going to impact the way these animals swim. So how you build your skeleton really is going to matter with what kind of swimming powers your shark is going to have. And in addition to having enough little pieces on your necklace or pieces in your backbone to produce wiggling, sharks have amazing and beautiful ways that they put the mineral into their skeletons. So here are some 3D X-rays called CAT scans of some species of shark vertebrae. We have a blue shark, and a mako shark. And if you look at the bottom here, you can see that some of the mineral is melted away, and you can see some of those really pretty patterns that you can get in the mineral. My favorite personally is the mako over here in the bottom right. I think they are super awesome, and there's going to be some fun stuff I can learn with their skeletons. But today, I want you to focus on swimming. So here we have some hammerheads swimming around in a tank. These are baby hammerheads that I was studying in Hawaii, and then we were also studying bonnethead sharks here in Florida. Now, these are baby hammerheads. I'm sure many of you probably know that hammerheads get to be very, very big. Some of those sharks can be bigger than 12 feet long. So, do you think it would be good for me to have the sharks that are 12 feet long swimming in my lab? No. It would take a lot to feed them, first off. And I would need some really, really big tanks. So we're able to study these little guys in the lab and then let them go. But how do we study this? This is where I'm going to teach you guys how to collect data and what we do in my lab, okay? So when you look at this shark, I want you to focus on how the body is wiggling around. It turns out we can actually learn an awful lot just by the way the shark is moving through the water. How fast is it wiggling its tail? That's really similar to how you have to move your legs really fast if you walk next to a parent or someone taller than you. And how far away is this tail moving from the center of the body? So you can see that this shark is moving its tail up and down. So let's look at this a little bit closer. So here we have just a still picture, it's a little blurry, of our shark swimming through space. So this is one of our hammerhead sharks. And the blue line shows the path that this shark had taken across the screen. So imagine our shark was swimming from this side of the screen, the left side of the screen, to the right side of the screen. And the blue line shows where the head went. And the red line shows where the tail went. Just by looking at these two lines, you can see a couple things about them. First, both of them have wiggles that go from the center. So they have peaks and valleys, like mountains and valleys. And you can see that the tail, the red line, has bigger valleys and bigger peaks compared to the blue line from the head. So what can we actually measure with that? Well, first is frequency. That is how fast does the shark wiggle? Does the head wiggle or the tail wiggle? And the frequency is what happens when you're walking next to your parent or adult that is taller than you. When you have to walk faster and almost run to keep up with them, you're increasing the frequency of your legs. So you're moving your legs a lot faster so that you can keep up. And so one of the things we can do is we can look at how many peaks. So hopefully you can see my arrow. At the top of the screen, these peaks and valleys, we can look at how many peaks we have over a certain amount of time. And so that can tell us that our shark has a certain number of tail beats per second. So if we pretended that this line, this picture of video was 1 second, we could count 1, 2, 3 peaks. And we could say that this shark was swimming 3 hertz. That's the unit that we use to describe that. So we had 3 peaks per second that this shark was moving. And that's how fast it's moving its tail. Another thing we can use to measure is amplitude. And that's how far from the center it wiggles. And so this is the big difference that we can see from the wiggly line produced here in blue from the head compared to the red line. We can see that the red line that shows where the tail went has a really big amplitude compared to the head. And so what that tells us about this particular shark is it's moving its head a little bit from side to side, but it's moving its tail a lot more. And so if we actually look at this in our swimming shark again, we can see that it's wiggling from back and forth. And we can see that the head is moving and moving back and forth. So we can get those measurements from the head, and we can also get them from the tail. And what we've been able to learn is not only how different species are able to wiggle their bodies to swim different speeds, and this is similar again to you walking with your tall grown-up versus someone your own height. Sometimes if you want to move faster, you're going to have to move your legs faster. And that's just like these sharks. If they want to move faster, they need to wiggle their tails faster. And the other cool thing we figured out from this study was bonnethead and hammerhead sharks, they wiggle their heads differently than the back of their body. That's really weird. So they have like two ways of wiggling their body to move, and we didn't really know that before. So that was pretty exciting. Another exciting thing we learned about this study is these hammerheads wiggle their body faster, but the bonnethead sharks move their tail. They increase that amplitude, so they just move their tail more. So they're doing different things, which is another really cool thing we found out, is different species are changing those things and making the way they swim a little bit different. So this is how I've started studying sharks swimming in the lab. And now you guys are all caught up with how we collect data in the lab. So when you stop by Florida next time, you'll have to come visit my lab and I can let you collect some data for me. All right, next time you come to Florida. So the next thing I want to tell you about is one of the fun things we're doing in my lab now. Because I don't know about you, I could watch these sharks swimming in this tank forever. It's really beautiful. Or when you go to an aquarium and you just watch the fish swim by all day, I could do that anytime. Swimming is so pretty to me. But one of the things we want to know is, how are these sharks swimming in the wild? So can we measure the way the tail and the body and the head wiggle from sharks that are out in the wild? That's my next big goal. And so here we can use drones. Drones are something that are becoming much more common in research, and they're also more common in our houses. Some people even have drones as toys. So what can we do with a drone? Well, remember, I live here in Florida, so we're lucky enough to have the beach right here. We can actually take our drone to the beach, throw it up in the air, and get some video of really awesome sharks swimming right in our own backyard. So here's a picture. You can see at the top of the screen these little bits of pink. Hopefully you can see my arrow still. These little bits of pink right here are people on the beach. And all of these black dots in the water are sharks in the water. So now I have the perfect opportunity to study the swimming powers of these sharks that come really close to the beach in Florida. So what am I able to do with that? Let's watch how this shark wiggles around, okay? Here he comes from the top of the screen. Now the neat thing about this shark is almost 6 feet long. And the little hammerhead shark I had in the lab, he was very small. He was less than 3 feet tall. So maybe about the height of some of you. So now we have the ability to study much bigger animals, and we can study them in their natural habitat, which is a really great thing. So now if we watch that shark, we can look at how far its tail is moving from the center. So how far does the tail go from side to side? Let's take a look at that. And we can see how fast the tail goes. So now let's count together. Let's let him swim down and let's count together and see how many times during this video the shark's tail goes to this side of the screen. Ready? 1, 2, 3. All right. And so our video is almost 3 seconds long. So that means this shark is moving its tail 1 time a second to get through this scene. Now, that's really good because he just looks like he's cruising around by himself, enjoying life as a shark. But what happens in different situations? Oops, let me get to my next slide. Here we have sharks swimming with buddies. Oh my goodness, look at all these sharks. Do you see them all? Now we can look at how their bodies wiggle when they're when they're swimming next to other sharks. And this is really similar if you've ever had to go someplace crowded. Like if you've ever been to the airport or like to Disney, the way you walk when there's no one else around you is a little bit different than the way you walk in a really crowded space when you're walking around surrounded by a lot of other people. And this is the same thing we think for these sharks. So one of the things we're studying now is how their swimming looks when they're swimming in groups. So you can see this first shark is swimming by, and here comes his second buddy, and here comes a big group. Like, do they have to wiggle their tails differently? And this shark are swimming very close together. And you can see, we'll wait till they loop again, their tails are actually very well synchronized, those two that are close together. They're wiggling them in the same pattern. So here you can see this guy and this guy. So this side, and if we want to take this very first shark and say, okay, 1, 2, 3, 4. He looks like he's swimming a little bit faster than the shark was in the other video when they were just by themselves. So we're starting to get an idea of what these animals can do in the wild as a group and by themselves. So we're learning a lot about how they swim together and how they swim in the wild in general. And why is this important? Because in this particular species, at least, these blacktip sharks, they're migrating down here in Florida. And so they're swimming in these very large groups, and they'll swim in groups to mate. We don't know. They'll swim in groups when they hang out down here. So they need to be able to coordinate their movements so that they can swim and get to where they're going pretty efficiently. And the last thing I want to show you, now that you know how to study how sharks are wiggling their bodies as they go along, is we can do this with a lot of species, right? We did it in the lab, and now we're doing it in the wild. And here we have video of a hammerhead shark and some blacktip sharks, and they are swimming around together, and that hammerhead is going to try to trace these blacktips. This particular hammerhead is pretty sad because he doesn't actually catch any. So I don't actually know if he's sad, but this hammerhead doesn't catch any in this video, but we can now look at the way these animals are swimming to get away from a predator. And we can look at how the predator is swimming to try to catch his prey, which is a pretty neat thing to be able to understand how these animals are swimming in the wild and during these really important predator-prey events. So with that, I want to show you guys, they're going to try to post this. It's our official FAB Lab member. So that's what we call my lab, is the Florida Atlantic Biomechanics Lab. And here's our lab logo. It was on my very front slide. But now that you all can collect data and know how to analyze data with me, you can be official FAB Lab members, and make sure you let me know next time you're going to be in Florida, okay? And so with that, I will leave you with one of my very favorite pictures of me and a shark. And this is a picture my mom doesn't like because I was very close to this shark. All right, so if you have any questions, just let me know, okay?
Fantastic. Thank you so much, Marianne. That was great. Some really cool videos and people are loving them. So we've got some questions coming through, and I guess first things first, what's your favorite shark?
My favorite shark, well, I really love these tiger sharks. Diving with them was truly amazing. But if I had to pick just one species, I would go with the mako sharks. Because at the beginning, I showed you that weird vertebra from its backbone with the really pretty mineralization. So they're weird that way. And if you've ever seen a mako shark, they are super sleek and streamlined. Like their nose is very pointy. They're like little torpedoes in the water. And they're some of the fastest swimming sharks. So they're my favorite for those reasons.
So is the way that their vertebrae is shaped and mineralized, does that impact how fast they can swim? Because we had a lot of questions about the speed of sharks.
Yeah, so I totally thought the way their vertebrae worked, the way that cartilage would squish together would impact the way they swim. And someday, I hope before I retire, I will be able to answer that question, but I totally think that's what's happening. And I think all those little plates of mineral around there help them do that, but I don't know the answers to that yet. So I will report back.
Yeah, and maybe someone watching can come and help you research it one day.
For sure.
So some of the other questions we had were about, they really thought that the drone research that you were doing was really cool, and interested in what type of drones you use, for example.
Oh, the drones, that's a great question. We usually use the DJI drones. They're just the ones you can buy at Best Buy. Nothing super fancy. We've had some waterproof ones in the past, and just in case my grad student flew it into the water. But it turns out my grad student's pretty good at flying the drone, so we didn't need to worry about a waterproof one. But yeah, just some of the normal ones you can just buy at Best Buy.
Cool. And then a lot of the other questions about that were, where do you go to study them? Do you stay in Florida? Are they beaches where people are as well? Or
yeah, that's a great question. And so we, for this particular study, looking at the blacktip shark swimming and the hammerheads, that all happens right here in Florida in Palm Beach County. But one of the things that make this field site so great, or this spot so great for studying this, is the water is really clear and it's really shallow. So we're able to see the sharks super well. And there are a few other places where we've been studying different species of sharks doing this. So we have a collaborator in California where they're looking at the leopard sharks that swim really close to shore. And we also have some collaborators in other parts of the world where you have this nice combination of really shallow, clear water where you can reliably see a lot of sharks. And the Bahamas is one of them.
Fantastic. Yeah, the Bahamas is one of the best places. I think about 90% of the people we've spoken to during the webinars have done research or are doing research in the Bahamas. Probably almost not 100%, to be honest.
Yeah.
It's such a special place.
Really
Charlotte and Pippa asked a great question. Why do sharks' tails go side to side when dolphins' tails go up and down?
That is an excellent question. And so a shark is a fish. And if you look at how fish tails move, they move side to side like this. And dolphins and whales, their tails go up and down like this. And this has to do with some of those big differences. Dolphins and whales are mammals. And so their backbone works like yours and mine. So they're evolved to kind of go up and down, whereas the fish tails go side to side. And so that's a really big evolutionary question. And yeah, we see that big difference in fish and in mammals.
Yeah, so we evolved differently a long time ago, and that's what happened. And it's also the reason why sharks' skeletons are made entirely of cartilage, which is one of the questions we got asked, is why is their skeleton made of cartilage? And the answer to that is evolution. You know, these animals evolved to adapt to their environment and the things they hunt, and lots of different other factors, and so we evolved separately from them a very, very long time ago, and they evolved the way they did, and we evolved the way we did.
Yeah, and so the really cool thing about sharks is some of the extinct species of sharks actually have little bits of bone on their skeleton. So we know from our fossils that sharks had little bits of bone and then kind of left bone and went straight for all cartilage. So they are really cool because they've survived for 450 million years with just this cartilage backbone, while nearly all other vertebrates have gone with a bony skeleton. So that is one of the other really cool evolutionary questions I can work with in my research as well.
Cool. And Charlotte and Pippa again ask you, do you study any other type of fish, or maybe animals in general?
Yeah, so some of my grad students are studying the lionfish that are really commonly found here in Florida. They're native to the Indo-Pacific, so you could normally find them on the Great Barrier Reef, but they're an invasive species here in Florida. So we've been studying some of the lionfish. One of my graduate students studies manatees and dolphins. And so, yeah, we are open to studying anything in my lab.
Very cool. And what's the type, do you study the same things in dolphins and manatees as you do in sharks?
Yeah, so the dolphin question is really interesting, I think. It's one of the bits of my research that I'm really excited about right now, because dolphins are mammals, right? We were just talking about that. And actually, the extinct relatives of dolphins lived on land. And then dolphins that we have now live back in the water. So we had this evolutionary movement from land to water. The other cool thing, so we've got that interesting evolutionary question. The other awesome thing about the dolphins is they live in water. So they're constantly being supported by the buoyant forces of water. So if you've ever floated in a pool or in a bathtub, the forces that keep you up floating, that's called buoyancy. And so these dolphins are living supported by the buoyancy of water all the time. And so we think they're a really awesome model for studying how to stay in space for a really long time. Because one of the problems with space travel is humans, we need gravity for our skeletons to stay strong. So it's really important that you run around and bike and jump up and down, because that keeps your skeleton healthy. But if you're in space where there's no gravity, you can't jump around. You can't like run around as easily. So our skeletons get really weak in space. So we think understanding how manatees and dolphins make their bone work in these buoyant forces can be a really great way to think about how humans can live in space, like going to Mars and living for a very long time, for example. So that's one of the things I'm really excited about with that research.
That's crazy. That's really interesting. Wow.
Dolphins in space.
No, yeah, exactly. And that's the thing, is that we still have so much to understand about the world around us and the world, the marine world, and the way things work, that it will definitely help us in the future, you know, to do things in space, or even on our own planet that we still are struggling to do with. And by looking at the natural world around us, you know, planes are very influenced by shark skin, you know, the shape of sharks, and so sharks are teaching us a lot about ourselves and how to make our world work. So yeah,
that's so cool.
Yeah, so cool. So I'm just having a look through the different questions. Cooper asks, how do they contact you if they want to, you said they could contact you, how would they go about doing that?
You can find my email address on my website. I think that they posted it on the Sharks for Kids. We can also, if you put a little note on there, I'll make sure I check it on Facebook, and I can do that. But yeah, I can have them If you just Google me, actually, it should work.
And
I think most kids know how to Google, but make sure you're okay to use the internet with your parents and trusted adults. Don't just go there by yourself.
Exactly. And you're on social media as well, I know, because I follow you on Instagram.
Yeah, I have Twitter and Instagram. That's way less active. And Facebook, we have our little lab page. But yeah.
All right. And I guess one of the questions that we ask everyone is a little bit of, can you give a little bit of advice to the children out there or the students out there who would like to, one, help sharks, and two, maybe go into a career like research or conservation in the future?
Yeah, so one of my best pieces of advice is to say yes to whatever opportunities come your way in terms of research and science. So it turns out I didn't always study sharks. I'm originally from Arizona, so I grew up in a desert. The very first scientific paper I published was on pine trees. I studied insects, and then I started to study plants that live near rivers in the water. And so it was actually quite a while before I started studying sharks. But because I said yes to all these other really great opportunities that came my way, I got a lot of experience being a scientist. And so that's probably the most important thing to do, is to work on your skills of being a scientist. Learn how to ask good questions. Learn how to collect good data and how to make a good experiment. And so we talked about part of that today, is how to look at data. Like, how do we start studying anything from these videos of sharks? Sure, they're pretty, but can we get anything useful out of them in terms of data? And so that's my biggest piece of advice, is to say yes to those things, because I said yes to this great opportunity studying plants and insects. And then that led to a really good opportunity studying plants on rivers. And with that, I got to work at the bottom of the Grand Canyon for 2 years. So that's a place where people will save and plan for their entire lives to go whitewater rafting in the Grand Canyon one time for a vacation. I got to work there for 2 years, and it was an amazing experience. And I learned a lot about being a scientist and how to be a scientist. So then when the opportunity came to think about where I wanted to do my PhD, I had a lot of options, including studying sharks, just because I had worked on my skills to be a good scientist. Because if you're a really good scientist, you can study anything.
Yeah, and it's really important to be a well-rounded scientist. I always tell people who ask me for advice on where they should get volunteering experience, I say, it doesn't matter if the lab is doing exactly what you want to do, but it's going to give you skills that are going to help you to get there. So you might want to study movement in sharks one day, but you could start by studying something in jellyfish, and it will get you there because you're learning the methods and the techniques. And so it doesn't really matter what animal you're doing it on to get experience. What matters is that you're building up that experience and taking any opportunity that comes your way.
Exactly. I mean, I honestly didn't expect to study sharks. I really love sharks. And like I said, I grew up in Arizona, so I was a swimmer my whole life, and I loved watching things swim, but I didn't know that was going to be my job in the future. And I'm very grateful that it is. But yeah.
So I guess the other question is, did you always know, so you didn't always know that you wanted to study sharks, did you?
Oh no, I really liked sharks since I was a very little kid. Jaws was one of my favorite movies. And I loved swimming, and I loved studying swimming. So I really liked that. And I knew I wanted to be a scientist, but actually my family, I'm the first scientist in my family. So my family was very supportive. They were like, okay, you go do what you want to do when you grow up. But they didn't tell me how to be a scientist. They didn't say, go to college here, go do this. And, I lived in Arizona. It's not like I could go to college somewhere and get a marine biology degree. I mean, I could have, but that would have been very, very expensive. So that wasn't really one of my options. So I Yeah, I've always loved sharks, and it's very cool that I ended up studying them because it does sort of circle back to my loves and joys as a child. But yeah, it was not what I expected I would do when I grew up. I wanted to be a scientist, but I didn't know I'd get so lucky to do this.
Yeah, and the world has changed a lot. It used to be that being a marine biologist and being a shark scientist weren't necessarily wasn't a common profession. It still isn't. But marine biology wasn't very popular until, well, actually, Jaws was one of the things that started people getting really interested in marine biology. And so that was one of the positive effects of Jaws, was that the generation that grew up watching Jaws, a lot of them studied to become marine biologists. But it used to be that people studied to be zoologists and then went into studying the marine world. So the world is changing all the time, and there's always going to be different routes and different ways to get into the things that you love doing. So it's really great that we get such a variety of people on these webinars, because they've all followed a different path and a different journey to get where they are.
Oh, for sure. And Jaws is one of my favorite movies for another reason. I grew up playing the violin, and so I love music. And the music from Jaws is like one of the most famous bits of music probably ever, right? And it's like this really amazing cello line. So, you know, I play the violin. So anytime we have famous string bits, it's always very exciting.
All right. Well, thank you so much, Marianne, for joining us today and for telling us all about your research. It was really interesting, and I'm sure that everyone watching enjoyed it. For anyone watching, if you want any more information, one about what Marianne does and about sharks in general, you can head over to our website. You'll find a link to Marianne's website on there, and sharksforkids.com/webinar. And you can find also lots of different resources, like coloring sheets, fact sheets, and lots more for students and teachers and parents alike. And so we really invite you to go onto the website to have a look and to follow our social media and Marianne's social media as well. And we hope you have a lovely evening or day wherever you are in the world. And same to you, Marianne. Thank you again for joining us.
All right. Thank you again for the invitation. And I hope you all have fun out there. And definitely let me know if you want to stop by the lab in Florida sometime. Okay.
Fantastic. Thank you so much.
Bye.
Bye.